2.8, the derivative as a function. So recall from 2.7, the derivative of the function f at a is defined to be the limit of this quotient as h approaching to 0. Now we're going to let a vary over here. We're going to replace this a by x. Then this becomes f prime of x is equal to limit of h approaching to 0. Now here will be f of x plus h, and here will be f of x, and then over h over here. Okay. Now let's call this equation 2. So this is the definition of the derivative of the function f, which is a new function that has been derived from the function f by this limit over here. Now notice that the domain of this new function f prime may be smaller than the domain of this function f over here. So take a look at this example 1. This is the graph of the function f over here. We're going to use it to sketch the graph of the derivative f prime. So remember, the derivative f prime corresponding to the slope of the tangent. So we draw a tangent line over here when x equal to 5 at this point P. We estimate the slope for this tangent is about 3 over 2. Now we can pick other points on this graph of y here. Okay. For example, notice that this point A, B, and C over here, the tangent lines are horizontal. So the derivative is going to be 0 here, here, and here. The slope of the tangent line are equal to 0. The slope of the tangent line here is about 3 over 2. So we're going to draw the graph for f prime directly beneath this graph right here. So that is corresponding to this A here, B here, and C here. The slope equals 0, so the derivative will be equal to 0. So the y coordinate of f prime will be equal to 0 here, here, and here. Now when x equal to 5, the slope is about 3 over 2. So y prime is about 1.5. So we have this point over here, 5, 1.5. And then we can pick more points on this graph of f, and we can estimate the slope of the tangent line at each one of them. And repeat this process, we can get the graph for f prime. So this is a graph for f prime, and this is a graph for f. Now notice that what happened over here is when you see on this part over here, the tangent line is falling from left to right. So the derivative, so the slope of the tangent is going to be negative. So you see y prime will be less than 0. So below this x-axis. Now from here A to B, you see the tangent line is going to rising from left to right. So y prime will be positive. So it's going to be above this x-axis, f prime. And from here to here, the tangent lines are going to fall. The tangent lines are falling from left to right. So the slope of the tangent will be negative. So from B to C, f prime will be negative. Then from here to here, after C, looks like the graph is going to have the tangent line to be rising from left to right. So f prime will be greater than 0 because the slope of the tangent will be greater than 0. So f prime greater than 0 here. Example 2. If f of x equal to x cubed minus x, find the formula for f prime of x. B. Illustrate this formula by comparing the graphs of f and f prime. So part A. So we're trying to find a formula for f prime of x over here. We're going to use the definition. It's the limit of this quotient as h approaching to 0. So this is by definition. That's the definition. Now we're going to substitute x plus h into this x over here, into this function. So this will be x plus hq minus x plus h. So this is f of x plus h. F of x over here is xq minus x. Now we take the limit of this quotient. To do that, we can expand this perfect cube over here. Remember, we reviewed the formula for perfect cube. So note x plus hq. Remember the Pascal triangle. The coefficient will be 1, 3, 3, 1. So it's 1 x cubed. So it's 1 x cubed plus 3x squared h plus 3x h squared plus 1 h cubed. So we're going to get this, expand this. We're going to get, this is the x plus h cubed. Okay. Now, minus x minus h and minus this plus x over here. Simplify this. We got 3x squared h plus 3xh squared plus h cubed minus h on top. Now divide by h, everything on top will divide by h. We got this expression here. So we're taking the limit of this function. Notice that over here, the h is changing. The x here is regarded as a temporary constant. So we substitute h over here to be 0. So we're going to get 3x squared minus 1. So this is the duality of the function f. So that's f prime of x. Okay. So you can see that it's a new function, and this new function is derived from this function f over here, okay, by this limit. Now we can use a graphing device to graph both the function f and f prime. So we can use a decimal graphing calculator. So we graph, this is a function f, and this is the function f prime. Okay. So you can see that they're related. F prime, think about that corresponding to the slope of the tangent of this f over here. You see for this f over here, the graph, you have a horizontal tangent here and also here. So at this two corresponding point over here, you see f prime will be equal to 0 here and here. Okay. Now, before this point, the slope is positive because the tangent line is rising from left to right. So f prime is positive. From here to here, the tangent line is falling from left to right. So it's negative f prime. Over here, the tangent line is rising from left to right. So the slope is positive. So f prime is positive over here. Okay. So this graph serves as a check on our work in part A. Example 3. If f of x equal to square root of x equal to square root of x, find the duality of this function f, and then state the domain of f prime. So we can find f prime using this definition. By definition, f prime of x is equal to the limit of this quotient where h is approaching to 0. Okay. So f of x plus h, we're going to substitute x plus h into x over here. And this is going to be square root of x plus h. F of x is square root of x. Now, notice that if we substitute h to be 0 here, you're going to get an indeterminate form of 0 over 0, which is indeterminate. So one way to get out of this indeterminate form, we talked about that, was to rationalize it. Okay. So to rationalize it, we're going to times the conjugate of this up and down. So which will be this plus square root of x. We times this up and down. Now, when we do that, so this in the numerator, we're going to get x plus h minus x, which is going to simplify into this h. Now this h and this h are going to be divided out. So giving you 1 in the numerator and this in the denominator. Now we can do a direct substitution. We're going to get 1 over square root of x plus square root of x, which is the same as 1 over 2 square root of x. Now we see that this is f prime of x. It's a new function derived from this old function f. Okay. Now, what's the domain for this new function? The domain for this new function is all real number strictly greater than 0, because the denominator cannot be equal to 0, and the x here is inside the square root. So the domain for this new function is all positive number. Now, which is slightly smaller than the domain of this original function f over here. For this original function f over here, the domain is all non-negative number. So you see this, the domain for f prime is smaller than domain for f sometimes. Okay. Now we can graph both function over here. This is the graph for the function f, and this is the graph for f prime. Now you see this f over here. If you draw a tangent line over here, you see the tangent line is going to be rising from left to right. So f prime will be always positive. So you see f prime is always positive, always above this x-axis. Okay. But before, you see the tangent line is steeper, but later on it's going to be less steep. So you see the slope is going to be decreasing. So you see f prime is actually decreasing. And yeah, so it's decreasing.